In this demonstration, we're going to expand on the examples using the select statement. For this example, we're going to be using these two tables. The employee table, which is the same table that we used in the previous demonstration, contains information about the employees for some fictitious company, and the person table, which contains the detailed information about each employee. These tables are linked by the Business Entity ID column. Notice that both tables contain Business Entity ID column names. So it is that piece of data that's going to link the information from these two tables together. And we're doing that because we want to get the employee's first and last name, which is not available in the employee table. We must link to the person table to get the employee's name. This is a common database design choice. It normalizes the data. It moves repeating data out of one table and into another table that is then linked by some key to the first table. In this case, the Business Entity ID links these two tables and allows us to access the data that we need that is stored in this second table. And just a quick review, we are using the Connect to SQL Server external file to generate the connection to our server, and we're using a class called Timer that's going to allow us to collect performance information about the execution of the select statements. Our first select statement is on line 14 and 15. We're asking the database to return to us the first and last name, job title, gender, marital status, and the current flag from the employee table linked to the person table. Because remember, the person table is where we're going to get the first and last name. And the link between the two tables is the Business Entity ID. So in our query to link those two tables on line 15, we write the keywords inner join. Then the name of the table that we're joining to, in this case, the person table. And what is the field that connects these two tables together? The common data element that links the two tables together is the Business Entity ID. So we're telling the database server wherever the business identity IDs are equal in these two tables, combine the row data in each table based on the equality of the Business Entity ID. Now, one quick note about aliases. You'll notice that we have provided aliases, another name for the employee table. And in our case, we're using E to represent the employee table. An alias is just a typing shortcut. It's another name for a table, and we're using P to represent the person table. This is merely a convenience. We could have just as easily typed person table name here and the employee table name here in place of the aliases P and E, and accomplished exactly the same thing. The alias tends to make the SQL statement a bit more readable and saves us typing as developers. We execute that query on line 16, assigning the result set returned by the database server to our internal variable results. Then on line 24 through 33, we loop through the result set, displaying the results on the browser. So let's see how this runs. So we've run our select statement with the join command that's linking the data from the two tables based on the Business Entity ID. There is no where clause limiting the rows returned, so we're getting all 290 rows of the employee table returned, matched with the data that exists in the person table for each row in the employee table. You'll notice that the result set now contains the first and last name of each employee, that data was contained in the person table, and we have access to that in our query because we combined the person and employee tables based on the common data field business entity ID. And accomplishing this select statement with the join required 5/1000ths of a second. Now contrast that with the execution of the select statement without the join that returned a limited number of columns but all 290 rows. That query took 1/1000th of a second. So there is a cost to the join. That's the key here. It's what we're trying to demonstrate, is that combining those tables based on the join condition on the database server requires resources, takes time. So this example joined two tables. Often we have data distributed in the database in multiple tables that we need to have access to in our select statement. That's going to require multiple join statements. So we're going to demonstrate that using this collection of tables. The data now that we're interested in getting from the database is not only the first and last name of the employees, but also their addresses. And because the database is well normalized, that data is spread across 5 different tables. Notice the link between the employee and person table is on business entity ID. In order to get the address of a person, we need to link the person table with the business entity address table. And notice the common data field is business entity ID. Both tables contain a business entity ID value. That's going to be the join condition. But that's not going to give us the address. What it's going to give us is an address ID. So we have to go to another table named address, whose key column is address ID. So now we're going to have to link business entity address with the address table and base that link between these two tables on the address ID field. But that's still not enough, because in reviewing the address table, we see that the state is not listed. Instead, a state province ID is listed in the table. So in this case, to get the state or province name, we need to link the address table with the state province table. And the common field between those two tables is the state province ID field. So we're going to link employee to person, person to business entity address, business entity address to address, and address to state province. In doing that, our query will have access to all of the information contained in all of these tables combined. So let's look at that code. We've tried to separate the select statement for readability. So from line 14 to line 18 represents a single select statement. So we're going to select the first and last name, address line 1, city, the name of the state, postal code from the following tables: employee, person, business entity address, address ID, and state province. The first step is to join the employee table. Again, we've given this an alias. It's just a shortcut to save typing. It's another name for the employee table. So everywhere you see an E, just simply replace that with the table name employee, and it has exactly the same functionality. It's just a convenience. So we're going to join employee with person, and we're aliasing person with P, and the join is going to be done on the business entity ID field between the two tables. That says take everything from the employee table, combine it with everything in the person table where the business entity IDs are equal between the two tables. Then, after doing that, combine that result with the business entity address table, and we're aliasing that with an A. Combine that with the person table, again on the business entity ID. So everywhere in the person table where the business entity ID is equal to the business entity ID in the business entity address table, those records are matched together. But that's not all, because next we're going to combine with the address table, and we're aliasing the address table with the C. And we're saying everywhere in the business entity address table where address ID is equal to the address ID in the address table, combine that data. But that's not all, because the address table does not contain the state name. It contains an ID that links to the state province table. We're going to combine the address table with the state province table, and in this case we're aliasing that with an S, and we're saying combine the address and the state province tables where the state province ID from the address table equals the state province ID from the state province table. Now we have a set of data from which we can select that contains the matching data from all 5 of these tables. And we'd make that selection partly from the person table. First name and last name comes from person table. Address and city comes from the address table, and the only way we could get to the address table was to link person to business entity address. We don't need any information from the business entity address. It's simply a link table. It links person based on business entity ID to an address ID. We need that address ID to get a person's address. And in this case, we're taking address line 1 and city and postal code. Those are the values that we're getting from the address table. We need the name of the state or province of the address. So we need to link the address table to the state province table based on the state province ID value. And that's going to give us the name which we ask for here in our select statement. And notice that in this case, so that there's absolutely no confusion about which name I'm requesting in the select list, I use the alias for the state province table, S dot the field name, in this case, name. So that's a whole lot of joins, bringing 5 different tables together to get us the data that we want for our query. So let's see how this runs. So there's our query as it was sent to the database server. And because we have no where clause limiting the number of rows returned, we received all 290 rows from the employee table. And that took 0.02 of a second to execute. Joins cost resources on the database server. Now, it's not our concern to limit the number of joins we use as a developer, because we need the data that we need to support the application. However, when we're doing these kinds of multiple joins to support the application, we need to make sure that we're interfacing with the DBA to ensure that that person, the DBA, is doing everything possible on the database server side to make this query run fast.